Right, we are rolling. Please stand. And let us pray. In nomine Patris et Filii et Spiritus Sancti. Amen. Sancta Michael Arcangelo, defende nos in prayer. Contra nequitiam et insidias diaboli, est presidium. Impere illi Deus, supliceste precam. Tuque, princeps militiae celestis, Satanum, aliosque spiritus malignos, qui ad benedictionem animarum pervegantur in mundo, divina virtute in infernum destruit. Amen. In nomine Patris et Filii et Spiritus Sancti. Amen. Please take out your homework 1D as in Douglas. Let me see what you got. I hate you see the crap I do that. So page 19-ish. I think it was just 1 through 11 up. Yep. We'll just.
I was swallowing water.
Make sure you get Dave on it. I can barely walk. Yeah, I'm gonna go through the parallel.
Hi, John.
All right. Okay. Yeah, you can get that by Monday. All righty. Did I miss anybody? Okay. And
Oh yeah. He doesn't use a TV.
this is the B. And you see. I have all of them. Yeah, yeah, I have. Okay, yeah, let me check those out. Yeah. And then 1D. Okay. So catch me for the end. All right. I have a. New pair of portable eyes here, so. Good to go. Grab a red writing utensil, have it at the ready. Again, we're on page 19, page 22-ish. And 1 through 11 on, let's see what we've got. Number 1A has 2 answers. They wanted you to plug in 2 and then -2. If you f of 2 should equal 1, and f of -2 should equal -2. Number 1B, find the 0 of f. Just out of curiosity, did everybody get that? I'll go through it today. It was a flashback from last year. 0 is short for something. And I'll tell you the answer. It's x equals 2/3. X equals 2/3. Ask me about that if you got stuck on that. Number 3, is f of 2 plus f of 6 equals f of 8? The answer, no, it is not. Number 5, part A. What are the slopes of their graphs? Both the slopes are 0. Part B, write them in the form f of x equals mx plus k. It's supposed to be mx plus b. They're just being goofy. Supposed to be, you can also do y equals in front. It's actually slope-intercept form. G of x equals 0x plus 2, and h of x is equal to 0x minus 1. If you wrote it as y equals 0x plus 2 and y equals 0x minus 1, that's fine. Number 7, What is the slope of, for part A? 1.5. What is the zero of the function? That's another that mystery one. See if anybody knows it. X equals 4/3. 4/3. 7C. The x-intercept is x equals 4/3. The y-intercept is y equals -2. Number 9. Find an equation for f of n. F of n, they're trying to play with your mind here. I'll show you what they did. It's supposed to be f of n is equal to -2n plus 12. -2n plus 12. If that totally and hopelessly confused you, I don't really blame you. I'll show you what they did. It's kind of sneaky. Number 11, sketch the graph of f. So there should be a point at 1, 5 and a point at 3, 9 and connect the dots with a line. Find an equation for that line. I have two different point slope equations. I also have a slope intercept equation if you want. The first one is y minus 5 equals 2 parentheses x minus 1. Or you could also have y minus 9 equals 2 parentheses x minus 3. Maybe have a different variation on that, yeah.
And slope intercept.
Slope intercept. Should be y equals 2x plus 3. That's better. Is everybody okay? 1 through 11? That was, oh, that's it. Questions? Repeats, I should say. All right, questions? Maybe you want to see the question about the zeros?
Yes, please.
Okay. What are zeros? Yeah. Yeah, put her back. If you have your notebook nearby, you might want to jot this in somewhere where you can find it. A solution, which kind of looks like this, x equals 3. When you find a solution, you get x by itself. A solution, there are 3 synonyms for this. So there are 4 terms total that mean the same thing. In other words, what's another name for solution? Anybody ever remember one? From years past?
Oh, wait, no.
Okay. Starts on R. Very short word. If you haven't seen this, root. Solution and root mean the same thing. Also, zero of the function. Zero of the function. I'll describe why they call it that in a second. And the fourth synonym is x-intercept. All 4 of these mean the same thing. I'll say if it's real. Does anyone remember from last year what kind of numbers are not real? Good. Imaginary, correct. By the way, they are coming back to haunt you today. Now, there are 4 different things up here that mean the exact same thing. A solution is a root, is a zero of the function, is an x-intercept. The book sometimes just calls them zeros for short. They're basically looking for the x-intercept. So just as an example for, what was the first one they asked you? Number 1b. Okay, f of x equals 3/4 x minus 1/2. I'm going to change this to y equals 3/4 x plus -1/2. So it's in slope intercept form. The question is, they wanted a 0. Now, first of all, I have to figure out what the heck they mean. A 0 is the same thing as a solution. It's also the same as an x-intercept. Well, people who remember the chubby hand method. If you're graphing something, say just crash this line through. This is an x-intercept. This is a y-intercept. Can somebody tell me something special about every x-intercept that ever lived? They don't live. There's something, there's a number about it. Yeah. There's a number that all x-intercepts have in common. Go. The y is 0. It's always something comes 0. Because the height is 0. Like if I crashed here, same thing. Here, here, here. Any point on the x-axis is going to be something comes 0. And conversely, can somebody tell me something special about every y-intercept? Katie, what do you think? Every x is 0. Correct. So how do you tell if you found an x-intercept if y equals 0? I'm going to put that up here. So in order to find an x-intercept, or a 0 of the function, or a root, or a solution, you set y equal to 0. In order to find a 0 of the function, and I'll tell you why they call it a 0 of the function in a minute. But I'm going to set this equal to 0. Okay, algebra people. I want x. Let me see. Spencer, help me out. What do you get rid of? I want to get x by itself. What do you get rid of first?
The negative over 2.
Correct. How do you get rid of it?
Subtract.
You can.
Well,
You can subtract the negative.
okay. You add a negative 1/2.
Add
Or
what?
add 1/2.
Add 1/2. Right. As long as you do it to
Both sides.
both sides. Nice. So 1/2 equals 3/4 x. Will, take over. What do you do now? Right. How do you divide by a fraction?
Oh, you multiply it by its reciprocal.
Correct. So you multiply by 4/3. These cancel. What happens here?
So you get
4 over 6. Does that reduce?
2/3.
2/3. And I would probably recommend. Yeah.
Here's the back.
Go for it. I would recommend that you reduce first. It's a lot easier multiplication. 2/3 equals x, and that's your answer. Okay. Now, what did you just get? Well, here's the graph of this thing. I'm going to go down to -1/2, and then the slope is 3/4. Let me just show you what it looks like. So, 1, 2, 3, 4. So you're up at 2.5, comma 4. You got x equals 2/3. Take a look, which you just found. Becca, what is that? What special point is that? Crash through the x-axis, it's called. It's an x-intercept. In other words, a 0 of the function is the same as an x-intercept. So if you find it easier to find an x-intercept, you're finding the exact same thing. Why do they call it a 0 of the function? Well, let me show you. F of x equals 3/4 x minus a half. Can somebody give me f of 2/3? Somebody step me through that. It's annoying to do a fraction, I'll be the first to admit that. But Abby, help me out here. What do I do here? What does that mean? Like, here's the formula. What does putting in 2/3 here mean? It is, but pretend you didn't see that. That was just me being artistic. So if all you see is this, what are they asking you to do?
Define the function.
Yeah, and do what with the 2/3?
Multiply it.
Yeah, plug it in. Multiply it by 3/4. Go ahead and do it for me. What's 3/4 times 2/3?
6/12.
Yes, which reduces to?
1/2.
Yeah. Well, and by the way, what happens to these?
Cancel out.
And then 2/4 reduces to?
1/2.
So this is 1/2, and then minus the 1/2. What do you get?
0.
Yeah. Let me say that again. When you plug in a 2/3, the function becomes 0. It's a 0 of the function. It's whatever you plug in and make the function 0. That's why they call it the 0 of the function. It's the exact same thing as an x-intercept. Always, always, always. Same thing as a root, same thing as a solution. Guaranteed. Everybody okay on what 0 means now? Yeah. Sure, sure, guys. Any other ones you want to see? Now's a good time to ask. Yes?
Number 9.
Number 9, yes. The graph of the linear function f has slope of -2 and intersects the n-axis. Yes. What in the name of all that's holy is the n-axis? Well, let me show you. Can somebody remember from yesterday? Down. What's another name for f of x? Very clear. You can replace it with what? If you want. This is making it look like a function. What if I wanted to graph it? Exactly. You can replace it with y. Y and f of x are interchangeable. Let me say that again. Y and f of x are interchangeable. If they give you something that looks like this, f of x equals 3x plus 2, it's the exact same thing as if they had said y equals 3x plus 2. One just looks like a graph, the other one just looks like a function. When would you have it look like a graph? If you're going to graph it, probably. When would you have it look like a function? If you're going to plug x's in and see what the answers are. Because functions are really good for that. Now, they had mentioned in number 9 the function f of n. We covered the other day what a function is, the pieces, what they're named. What does f stand for? It's the what? Look back in your notes if you need to. It's the what of the function. Where's there anything now? Go. It's the function's name. What's n? Yeah. That's the input variable. What input variable do we usually use? What do most mathematicians in the world love to use as the input variable? If you just make your own function, what do they usually use as the input variable? They're almost addicted to it. It's usually f of what? X. Almost all people use x as the input. You don't have to. They're using n. Now you've done something a little creepy in graphs. Well, take a look up here. And by the way, I would like to keep the three of you together, but if it causes chit chat and distraction, I'm not going to allow it. Clear? What is this axis called? Sorry, no, x-axis. That's old-fashioned. What's the other one called? It's the y-axis. It does not have to be called that. 400 years ago, Rene Descartes designed graphing and used x's and y's as his first graph. And then people just caught on. There's no cosmic reason it had to be x and y. It could have been anything you wanted. What if I had done this? T and W. Here, the name of the function is f of x, like y equals f of x. Look at the pieces and look where they are. And then just using your knowledge of patterns, just say, gee, this stuff made this. Can anybody give me an equation like that using the new letters? I'll give you a hint. This is the input variable. The input axis is always left-right. The output is always up-down. That's never going to change. They can change the letters on you, but they'll never change that. The input, unless they're crazy. The input axis is left-right, the output axis is up-down. Can somebody tell me what this would be called? Just use this formula, y equals f of x. And let's just say this will be a function, f of whatever. So something equals f of something else. Can somebody tell me what letters it means? Just like, yeah.
You mean like f of t, or wait,
Yes, f of t. What is equal to f of t?
w?
W equals f of t. Does that make sense? This is the input. This is the output. The input is always the left-right axis, no matter what they call it. The output is always the up-down axis, no matter what they call it. Let me try another one, see if we can get this. Here's another thingy. L and A. And use the function f. But name it for me. So something equals f of something else. Somebody tell me what it would be. Just using the pattern.
A equals F of L.
Got it. A equals f of L. This might be a realistic example. If you're trying to find the area of a square and you have one side length, L could be the length of the side and A is the area. You might want to use letters other than X and Y. Again, 99.9% of the time when we graph, we do X and Y, but we don't have to. Now, let's go back to this problem. Number 9, f of n. Now, they didn't tell us what the output variable was, or did they? Oh, they just said call it f of n. F of n is equal to basically something variable plus something. It's normally mx plus b to graph a line. Because I said number 9, the graph of the linear function, that's a line. Slope of -2, and it intersects the n-axis at n equals 6. What are they talking about? Can somebody tell me which axis is the n-axis? Just looking at this. I didn't give you a lot here. Just look at this. Which, yeah. It's the x one. It's the left-right one. This is the n-axis. And I have no idea what they want to call the other one. We can still call it y if we want. Unless they specifically order us to tell us something else. So basically y equals this stuff. So it's going to look like this. Y equals something times, am I going to use x in this problem? What am I going to use? N. Blah, 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 n plus blah, blah, blah. It's going to look like that. Guess what goes here? Go. The slope. -2. What's supposed to go here? N. What normally goes here in slope-intercept form? The y-intercept. That's still true, by the way. Now, they did say the slope of -2, and it intersects the n-axis at n equals 6. Did they give us the correct intercept? Now, to finish this problem. What kind of intercept did they want here?
The y-intercept.
Y-intercept. Is that what they gave us? No. They gave us the n-intercept, which is kind of like the x-intercept. Okay, math people. Find what the y-intercept is. Is there any way on earth to do that? They were trying to fool you by renaming the x-axis n to see if they could distract you. But you do it, if this were x, how would you find the y-axis, the y-intercept? Is there any piece of information up here at all they could do n? Okay. What do you think? Yeah.
Do that n equals 6.
N equals 6 is kind of like the x-intercept, so it's 6 comes 0. They want the y-intercept. How do you find it? Because they didn't tell you where it was. Use the slope. The slope is -3/1. That means if you go from here down to right 1, down to right 1. Can anybody think of an idea of how to get the y-intercept based on that? Can you tell me, do you think the y-intercept is gonna be above or below 0? What do you think? It's above. If you follow this back, it's actually way up here. Somebody find it. Where's the exact location? Brainstorm. Tell me how to get there. Yeah.
Hit 12?
It is in fact 12. How do you get that?
Since this one is 2, just start with like 6%.
Yeah, if you go back 1, you go up 2. What if you went back 6? You go up 12. Exactly. You just found the magic number that's supposed to be here. So your answer is supposed to be y equals negative 2n plus 12. Or if that is equal to negative 0 plus 12. Just in case anybody's totally stressing about this, this is, I'd like people to be exposed to this is called renaming a variable. I'd like people to be exposed to it. Maybe you could breathe a sigh of relief on this. You're not going to be tested on it. I want you to see it, because in college, if you take another math course, they do this on occasion. And I don't want people freaking out. Because every once in a while, they'll have T and W, and they want to make sure that you know this is W is equal to F of T. Okay. I'd like you to have seen that at least once. But you're not going to be, it's not going to sink your grade in this class. Okay. It was a good problem, but nothing big. Next. Anything else? Any other questions? Going once? Going twice? All right, check out your notes, please. I want to talk a bit about non-real numbers. We touched them last year. We played with them a bit. I'll leave that a little bit. Non-real numbers. Can somebody tell me how to get them? Like, when do they occur? What causes a number to be non-real? Awesome.
Square root of -1.
Mm-hmm. The square root, or radical, of any negative number. The square root of any negative number will give you a non-real number. For example, can somebody tell me what radical -1 is actually called? It's called I. It's lowercase I. I usually write it in italics, that's why it looks kind of swoopy. You can write it as regular I. Regular I looks kind of like a 1, so that's why I avoid it. So can somebody tell me what this is? What's radical -4? Before you answer that, let's see if you remember this. Can somebody reduce radical 12 for me? Remember that? Go. Yeah, how do you get that? Right, radical 4, radical 3. What's good about radical 4? Perfect square. So then that boils down to what? 2 radical 3. You can split radicals up, and it's nice if you can split off a perfect square. Radical -4. Just try that. Sam, help me out. Is there a perfect square in here? Multiply. 2's not a perfect square though. Square root of 2 is 1.4 something. Is there a number that you can divide this by that's a perfect square? Think bigger. There's really only one other option. It does divide by 2, but 2 isn't a perfect square. Go bigger.
4.
Yeah, 4. Radical 4 times radical what?
-1.
-1. Can you boil that for me? What's radical 4 really? Same as the square root of 4, it's positive. square root of 4? What number times itself is 4?
2.
2. What's radical negative 1? I. Dash. Radical negative 4 is 2i. Try this. Radical negative 12. Okay, take this one. Is there a perfect square in there?
Yes, there is.
Like what?
And then
4. So radical 4 times what? Negative 3. I agree. If you could split off the negative 1 at the end, that would make it look better. So what was it about? Positive 3. Everybody see it? I could have left it as negative 3, but splitting off radical negative 1 is useful. Because what does that turn into? So what's this? 2. What's radical 3? Trick question. Yeah, it's radical 3. And I would put parentheses around this so that people don't think that the I is in the square root. It's 2 radical 3 times I. Yeah. So that, you remember that, is that ringing a few bells? This is reducing radicals and reducing imaginary numbers. Because imaginary numbers are radicals. They get a little more exotic. An imaginary number is the square root or radical of a negative. So what we call pure imaginary, go ahead and write this down. Is basically bi, where b is a real number and I is radical negative 1. So for example, 2i, negative 3i, 4 over 5i. You can get really exotic, radical 7 times I, and so on. Any real number, no matter how nice or icky, times I, would be called a pure imaginary number. There is also another non-real number that's not pure imaginary. It's called complex. A complex number is basically a real number plus an imaginary number. It takes the form A plus BI. A plus BI. Where A and B are real numbers. And I is radical negative 1. That's called the complex number. A real plus an imaginary gives you a complex. For example, 3 plus 4i. Sorry, that was a bad I. Negative 5 plus 6 over 7i. Radical 2 plus radical 3 times I, and so on. In other words, any two real numbers you want, one by itself and one of them welded onto an I. That's called the complex number. And last year we played with these and we did arithmetic on them. Add, subtract, multiply, divide. Let's take a look. Example. I'm going to call capital A and capital B. They're going to be some complex numbers. A is 4 plus 5i, and B is 3 minus 2i. Go ahead and write those down. Some of these arithmetic steps are quite easy. Some of them are a little more exotic. Can somebody tell me A plus B? I want to add these two complex numbers together. 4 plus 5i plus 3 minus 2i. Go.
7 plus 3i.
You got it. How'd you get that so fast?
Just add each term together.
Right. You add the like terms. That's all why you do. You treat I sort of like a variable, temporarily. It's not. It's an actual value. It's an imaginary value. But you can treat it like a variable as far as combining like terms. All right? Somebody do A minus B. I'm going to write this out. 4 plus 5i in parentheses minus 3 minus 2i in parentheses. Curious if anybody knows why I use parentheses. I mean, I always do when I plug things in, but especially in this case, why?
Distribute the negative side, the subtracting side.
Exactly. I hate subtraction. Add the opposite. Distribute, distribute. Add the opposite. So it's going to be 4 plus 5i plus negative 3 plus positive 2i. Did we catch that? Positive 2i? Okay, finish it off for me. What's the final answer on this thing?
1 plus 7i.
Got it. 1 plus 7i. Good. Questions? You doing okay so far? Get some space here. I don't want to go past the dotted line because then the camera doesn't pick it up. By the way, if anybody wants a link to the video on this, if you just want to go over the lesson again, let me know. Just send me an email and I can send you the link. Or you can just click subscribe, in which case you get an alert as such. I don't get any money for it, so you're safe, as far as I know. If I start getting money in my PayPal account, I'll let you know and I'll share it with you. So we've got this, A times B, 4 plus 5i times 3 minus 2i. How on earth did you do that? Randy, help me out here. Binomial times a binomial. How do you do that? Bingo. What? Do it for me. 12. Sorry, kill me. I just had to get my homicide out of the way. Go ahead. Negative 8i, good. 15i. And then this is going to be interesting. And then I times I is I. Oh, that's true. Or just I.
Oh.
Kind of like x times x. It's I times I is I what? To the second. Good. If that's what you said, congratulations. Merry Christmas. Now, does everybody see where they came from? It's just foiling, it's just multiplying. There are two things you can do to simplify this thing. Nate, help me out here. There is something in here that can be boiled down. Name one. There are at least two things. What's that? Kind of, sort of. Like, what do you mean? Okay, so they can combine. What's negative 8i plus 15i? 7i. So it's 12 plus 7i plus, does anybody say anything else that was boiled down? I'm curious if you remember from last year. Yeah. What is I squared? Is what? Very close. It's negative 1. Let me prove, remember that from last year? If you don't, look up here. Radical negative 1 is I. Square both sides. The square root and the square cancel. I squared equals negative 1. I squared is negative 1. Let's see who remembers the other ones, by the way. Let me do it over here. I to the first is I. I to the second is negative 1. Can anybody tell me what I to the third is? Yeah. Negative I. What's I to the fourth? Anybody? Yeah. It's 1. How'd you get these last two? They're not as obvious as this one. This one you just square both sides and poof. Where did this come from? How do you know it's negative I? I mean, by the way, bravo for remembering that. But it's got to come from somewhere.
Basically, you're just cubing the radical negative 1.
Uh-huh.
So it's by squaring radical negative 1, that's
Okay.
negative 1, and then negative 1 times 5.
I need to focus up here. No, sure. Yeah, this Radical negative 1 makes negative 1, right? And what is radical negative 1 again? I. It's negative 1i. That's where it comes from. Another way to put this is I to the 4th is really I squared times I squared. Which is negative 1 times negative 1. Which is 1. Did anybody tell me I to the 5th? Remember, yeah. It's I. What's I to the 6th? You remember? Negative 1. What's I to the 7th? Just keep going. Negative I to the 8th? Where are you getting these? Yeah, what's happening? It's repeating. Every 4, it cycles. It gets 4 answers and then it repeats forever. So I to the 8th is 1, I to the 12th is 1, I to the 16th is 1, I to the 400th is 1. Every multiple of 4, power of I, is going to give you an answer 1. Okay? Fair answer? Now, I want to look up here. Let me get this stuff out of the way. We were talking about, let me get this stuff out of the way. There's 12 plus 7i plus, somebody tell me what that is, please. Negative 1. So negative 10 times I squared is really negative 10 times negative 1, which is what? 10. Combine the like terms for me. 22 plus 7i. Done. There you go. You feeling okay, sir? The book will also do one more thing. It'll ask you to divide. Let me show you a flash from the past. This is from second year algebra, probably. Gentlemen? Remember? Can anybody tell me how to fix that? What's wrong with just leaving it that way? Sam?
There's the radical on the bottom.
The radical on the bottom. Abby, help me out. How do you fix that? How do you get the radical out of the basement?
Multiply by its reciprocal.
Kind of, sort of. Multiplied by something, same thing on top and bottom.
Oh.
So what?
Just get a common denominator.
Sort of. In other words, you use the exact same thing. One way to think of it is the only way to kill a radical is with another radical, which, by the way, is totally not true in the real world. But in math, the only way to cancel a radical is with another radical. Because when you multiply these together, it squares and it cancels the square root. So tell me what that would give you, by the way. Abby, go ahead. What's the top? What's 3 times radical of 5? Don't work too hard.
15 radical.
If they were radicals, yes. Oh, I should tell you. Sorry, I skipped a step. Everybody look up here for a second. This is arguably the dumbest question I'll ever ask you. What's a number times a number? A number. Congratulations, yes. What's a radical times a radical? A radical. What's a number times a radical? Yeah, number radical. I'm not kidding. So in other words, 2 times 3 is 6. Radical 2 times radical 3 is radical 6. But 2 times radical 3, you just mush them together. Does that kind of make sense? So in this particular case, what's 3 times radical 5?
3 radical 5.
Exactly. There's not much else to do. And can somebody tell me what the bottom would be? Back up. What's radical 5 times? Radical 5 times radical 5. Radical 25. What is that number really? It's 5. Another way to think of it is radical 5 squared. And the square and the square root cancel. They make 5. Feel a little okay on that? Now, this is actually way back from first year algebra. We covered it again in second year algebra. I'm gonna cover it again now. It's called the hostage situation. You have a radical in the basement. You can't leave it there because it builds bombs, blah, 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 blah. But normally, you just say, radical in the basement, other radical, go down, kill it. Well, not kill it, drag it upstairs so it didn't die. It's up here. But at least it's upstairs where you can keep an eye on it. It's on the upstairs sofa where it can't build bombs. This thing. All right, there's another radical down there. And then the radical happens to have this thingy with it. Here's the radical. Don't come near me. I'll blow this two's head off. I'm serious. No, Sandy, I'm too young to die. How do you get it out of there? You remember? He has a hostage. You can't just take a grenade. Sayonara. Or can you? Yeah. 2 minus radical 5. That's an excellent question. Isn't that going to kill the 2? Well, that's kind of heartless, isn't it? Yeah. Okay. Well, you're honest. But what allows you to do that? It's going to say, "Sorry, hostages. We never covered how to recover hostages alive in my classes. Bye." No, you got to do. There's got to be a reason. There is. This is a radical in disguise. 2 is radical 4. It's another radical pretending to be a hostage. So you have absolutely no moral qualms about going, sayonara, people. Bam. In other words, you can kill everything in the basement with a clean conscience. So question, how do you kill radical 5? How do you cancel radical 5? You want a little less bloody. How do you cancel radical 5? Like up here. Like what math operation?
You multiply
Multiply by radical 5.
Yes.
Oh, where? Top and bottom. How do you cancel, I'm going to let the secret out, how do you cancel a radical 4? Kind of the same answer.
So, you just put a 2 in the bottom.
Yeah, a radical 4, feel free to call it a 2, is wearing a nice innocent mask. Let it keep its mask while it gets blown to shreds. How do you kill, how do you cancel a plus?
Negative.
Minus. Those are the 2 minus radical 5 came from. This has a special name, by the way. I do want you to memorize it. It's actually a non-violent name. It's called the conjugate. Which basically means you switch the sign of the radical. Switch the sign of the radical, of one radical. Let's put it that way. If there are 2 radicals, you just switch one of them. By the way, there are 2 radicals, just one is obvious, one is not. Let's see what happens. Let's see if this experiment actually works. On the top, you're supposed to do 3 times 2 minus radical 5. On the bottom, you're supposed to do binomial times binomial. How do you do binomial times binomial? Okay, help me out. Do the top for me. 6? Right. 6 minus 3 radical 5. How do you do the bottom? Binomial times binomial. Foil. You're going to foil this bottom. So take over, Megan. Foil these 2 things here. Minus 2 radical 5, good. Plus 2 radical 5. And then minus radical 25. What is that really? That's fine. Does it miss anything that simplifies? Blaze, help me out. On the bottom. Yeah, the 4 and the negative 5 will combine. What is 4 plus negative 5? Negative 1. Anything else on the bottom?
The two rapid fire and the two rapid fire cannon.
These cancel completely. So the bottom is -1, and the top is 6, forgive me, plus negative 3 radical 5. Oh, math wizards. Oh, Spencer. What happens when you divide something by -1?
Wait.
It's not a trick question.
Oh, it becomes negative.
Right. What if it's already negative? What if it's already negative?
Becomes positive.
Then it becomes positive. In other words, it switches the sign. Do it.
6 plus 3. divided by
What kind of 6?
Negative 6.
-6 plus 3 radical 5. You're looking at your answer. That's how to get rid of a radical out of the basement. Okay, good news and bad news. The bad news is we're slogging through a lot more notes. The good news is I'm afraid I did not get through them today. So you have a weekend to frolic, swim in ice cold water, pass a humanities test, whatever you want to try. We do have about 3 minutes left. Frankly, go ahead and let your brains cool off. We're good to go. So there is no homework for the weekend. Homework 1E is an Egbert. Will be due on Tuesday of next week. Fair warning now, I do have an announcement. Let me get back to the board so I can tell you what I'm talking about. According to my eyeball scan of the chapter, E, F, G, H are the last 4 homeworks. They're going to take a little while, but expect a test not next week, but probably the week after, the end of the week after. So 2 weeks from today, you can probably expect a chapter 1 test. Okay. We'll have plenty of stuff to go over. People who haven't had me before, or people who haven't had me in a while, I do practice tests 2 days before the actual test, so you should have a good idea of what's on it. That'll probably be the Wednesday of that week. And then we go over it on Thursday, take the actual test on Friday, and boss your uncle. Okay. Good enough. So take a minute or so, then I'll have you I'll call you for prayer.
Wait, what about the?
Few minutes. Oh, sorry. Yes, good catch. For those of you listening at home, God bless you all. This is my hand waving goodbye. Talk to you later.